Assalamu alaikum warahmatullahi wabarakatuh. Good morning everyone. How are you? I'm Jana Ahmad Sadiq, and today's topic is talking about chemical reaction and stiochemetry. First of all, chemical reaction is a process which reacting substances called reactions and converted to new substance which are called products. First of all, chemical reaction is a process in which reacting substances called reactions and converted to new substance which are called products. Now, in this example about chemical reaction, it says that reactants will give us always products. It will be converted products. Now, like for example, magnesium plus oxygen will give us magnesium oxide. Here what we have, this chemical reaction, first of all, magnesium and oxygen are in the right side, which they are called reactants, and in the left side, which we have the product, it is magnesium oxide. Now we will go about the chemical equations. First of all, a chemical equation is a shorthand representation of a chemical reaction. It is a shorthand that represents the chemical reaction. Now here, like for an example, balancing chemical equations. First of all, it can be by two ways. It will be by the inspection method, and the second one, it will be by the Lcm method. Like for example, the first one, which is hydrogen plus oxygen will give us water, right? Okay, here it's not balancing, it's unbalanced. Why? Because we have two hydrogen here and we have two oxygen here, but we have here two hydrogen only, but we have only one oxygen. So how can we balance it? First of all, it is an inspection method, so that means you will put a number by your mind by looking only, without making like by the Lcm method you will make a ways that you will use the numbers, but here you will not use anything, only guessing. Like for example, here we have two hydrogen, two oxygen, two hydrogen, one oxygen. We want to make this oxygen 2, so we will put 2 here in the coefficient place. Now what we have, 4 hydrogen and 2 oxygen. Okay, but we have in the reactant place what we have, 2 hydrogen. We want to make it 4. So we will put the coefficient for hydrogen in the reactant, it will be 2. So now it is balanced. Why? Because we have 4 hydrogen in reactants and 4 hydrogen in the products. We have 2 oxygen in the reactant and we have 2 oxygen in the product. Now, the second method is by the Lcm method. Lcm method, that means to know the valence number of the elements to find their coefficient. Like for example, what we have here, aluminium plus oxygen will give us L2O3. Okay. Now we have only one aluminium here and we have 2 aluminium here. We have 2 oxygen here and we have 3 oxygen here. The valence number of aluminium is 3. So we will put 3 up of aluminium. Then what we have here, 2 oxygen. But the valence number for oxygen is 2. So what we have here already, 2. 2 times 2, it will give us 4. Okay. Here Al2 and O3. First of all, 2 times 3, it will be 6. And what we have here, 3. 3 times 2, it will be 6, the same thing. So we'll take only 1/6 of them, that it will be the coefficient of the both elements. Now, what is the Lcm, or what is the number that is similar in 3 of them? Like it is in 3, the number which is, it will be in 3, and it is in 4, and it is 6. The number 12. Number 12 is the Lcm of number 3, 4, and 6 together. So what will make? We'll make 12 here. Now 12 over 3, 12 over 4, and 12 over 6. So that means what we will do by 1 and here by 4, by 1 and here by 3, by 1 and here by 2. So at the end, what will make 4 aluminium plus what we have here 3 oxygen will give us here only we will take one coefficient of them as we said that only will take 1 6 and we will make 12 over 6. It will be 2 aluminium and O3. Now we want to see if this equation is balanced or not. What we have here 4 aluminium, right? Okay. And we have here what? 2 aluminium. No, actually we have 4. Why? Because in the coefficient we have 2 and for aluminium already we have 2. So 2 times 2 it will give us 4. Okay, so that means aluminium in reactants and products are equal. What about in oxygen? We have here what 3 times 2 it will be 6. And do we have here also 6 in the products? Yes. 2 which is the coefficient times 3. It will be 6. Because the coefficient it is for the 2 elements. So that means we have 6 oxygen in the reactants and 6 oxygen in the products. Now let's see some another examples about balancing chemical equations. Now let's continue by the first example of chemical equations. The first one says sulfur oxide plus oxygen will give us sulfur trioxide. Okay, now this equation is not balanced, is unbalanced because we have here what? 1 sulfur. And what we have here also 1 sulfur. Okay, sulfur is balanced in the both products and reactants. But in oxygen, here we have 4. Why? Because we have here 2 oxygen with sulfur and what we have here 2 oxygen also. So 2 plus 2 will give us 4 oxygen in the reactants only. But in the products we have only 3 oxygen. So oxygen what we have here in the products is 3 and in the reactants it's 4. We want to make them balance. So what we will do here, we will put 2 in the coefficient. We will put 2 coefficient in the products. Here 2. Why? Because 2 times 3 will give us 6. Right? And if we put here also 2, what we will have here? First of all, 2 sulfur. And here we will have 2 sulfur. So sulfur in the both case we will balance it. But in oxygen here what we have 2 times 2 we have 4. Then 4 plus 2 it will be 6. So oxygen in the reactants it will be 6 oxygen. But in products we have here 3 only. 3 oxygen and what we have here in the coefficient 2. So 2 times 3 will give us 6 oxygen. So that means it will be balanced if we put here in the coefficient of sulfur dioxide 2 and the coefficient of sulfur trioxide 2. So that was the first example of chemical equations. Now let us go for the second example. Now let's continue by the second example, which is says 2 hydrogen plus 2 nitrogen will give us NH3, which is ammonia. So here it's unbalanced because we have 2 hydrogen here in the reactants and in the products we have 3 hydrogen. we have 2 nitrogen in the reactants and 1 nitrogen in the products. So how can we balance it? First of all, we have 3H here, so we'll put here 2 and we'll put here 3 to be the same thing, because we have 3 for hydrogen, so we'll put the coefficient 2. And we have here 2 the substrate of hydrogen, so we'll put 3 as a coefficient, like crisscross. So what we will do here, I think now it will be balanced, because 6 hydrogen and here also 6 hydrogen, 2 nitrogen, and also we have here 2 nitrogen. So in the reactants and the products, now it is balanced. Now let's go for the types of chemical reactions. I think you know about the combination, decomposition, single displacement and double displacement, and redox reaction. Now we will see all of them and their examples together. Now let's continue with the types of chemical reactions. First of all, the first reaction says about combination reaction, which is A plus B will give us AB. That means one element plus another element will give us a compound. The decomposition reaction, which is the product, it is 2, and the reactants will give us 2 products or more. The same like combination reactions that we have in the reactants, single elements or more reactants can give us 1 product. The product will be 1, but in the decomposition reaction, the reactant it is 1 and the product are more. Single displacement reaction, which is A plus BC, will give us AC plus B. Double displacement reaction, which is the fourth reaction, which is AB plus CD, will give us AD plus CB. Now, by these reactions, we have some examples. We'll identify them if they are one of these reactions or not. First of all, chlorine plus 2Ki will give us 2KCi plus I2. What we have here? A, 1 element. What we have here? 2Ki. Actually, K is a potassium, I is iodine, so that means we have 2 elements, A plus B, C. Will give us 2KCi plus I2. That means AC plus B. Right? Which reaction is this? Actually, it is the single displacement reaction, because A plus BC will give us AC plus B. So that means this one is a single displacement reaction. Now, the second example, which is says H3PO4 will give a plus 3LiOH will give us Li3PO4 plus 3H2O. Actually, this one what we have here, we have AB plus CD will give us AD plus BC or CB. Let's do it together. A plus B will give us CD, which is AD plus CB. So that means this reaction, it will be for double displacement reaction. Double displacement reaction. Now, in the third example, what we have, 3HNO2 will give us, 3HNO2 will give us HNO3 plus H2O will plus 2NO. So that means in the reactants we have only 1 product, and in the products, in the reactants we have only 1 compound, but in the reactants or in the products we have three, three compounds. So that means it is a decomposition reaction. As we said before, that AB will give us A plus B. We can say also A plus B plus C plus D. So this reaction, it will be decomposition reaction. Now, in the fourth example, say CaCO3 plus H2SO4 will give us CaSO4 plus H2O plus CO2. Now what we have here, AB plus CD will give us AD plus CB plus another one, which means like CD, or another like CO2, the same thing. So H2O plus CO2 plus CaCO4. So it will be double displacement reaction. Now the fifth question, it says 4 of iron will give us 4 of iron plus 3 oxygen will give us 2Fe2O3. So that means what? Two elements, A plus B will give us AB. So that means this reaction will be 4 combination reaction. Combination reaction. Now, after knowing the types of chemical reactions, now let's go for the oxidation and reduction elements. Now let's continue with the oxidation and reduction reaction. First of all, oxidation is the addition of oxygen and removal of hydrogen, and is a process of losing electrons, like for example metals. And in reduction, addition of hydrogen and removal of oxygen, and is a process of gaining electrons. That means there are examples like nonmetals. As you know here also, sodium plus 1 electron will give us Na positive, sodium positive. So this is an example of oxidation. But in reduction, chlorine plus 2 electrons will give us negative chlorine. So that means chlorine will gain electrons from metals. Now, oxidation number or oxidation state. First of all, is the formal charge of one atom with respect to another. Can be 0, positive, negative, 3 of them. Now there are the rules for this oxidation number. First of all, oxidation number in all elements or molecules in its free state is equal to 0. Like for example, oxidation number of sodium, if it is alone, if it is in its free state, will be equal to 0. Cu, which is copper, will give us also 0 because it's in a free state. It's in its free state. Chlorine, also the same thing. It will be 0 because it is alone. Now, oxidation number of group A or group 1A is always positive 1. And group 2A is always positive 2. All the elements inside this group is plus 1, which is in group 1A. But in the group 2A, all elements inside, it will be plus 2. Now here, oxidation number of monoatomic ion is equal to its ion charge. And this is the same thing with the polyatomics. Now here, like for example, aluminium plus 3 will give us plus 3. The oxidation number of aluminium will be also plus 3, positive 3, because its charge, its ion charge is positive 3. So oxidation number of monoatomic or polyatomic, it will be the oxidation number, the ion charge of this element, it will be their oxidation number. Like for example here, acetate aluminum, their ion charge, its ion charge is positive 3, so the oxidation number, it will be positive 3. And in sulfur, which is negative 2, the ion charge of sulfur is negative 2, so the oxidation number of sulfur, it will be negative 2. And also there's so many proatomic and monoatomic ions that their ion charge is equal to their oxidation number. Now, the fourth rule, which is halogens. Do you know which group halogens? Actually, group 7. Group 7 except oxygen. Except oxygen, all of group 7 is equal to negative 1. But positive 1 with oxygen. So that means all of group 7 except oxygen, it will be negative 1. But it will be positive 1 with oxygen. When they will react with oxygen, they will be positive 1. Okay. Now here in the fifth rule, which says hydrogen is what? Hydrogen is positive 1. But positive 1 with what? With non-metals, and negative 1 with metals. So hydrogen can be plus 1 and negative 1. Hydrogen with the non-metals, it is positive 1. But hydrogen with metals, it will be negative 1. Now, in the sixth rule, which says oxygen in the most of its compounds is negative 2. But in a peroxide, it will be negative 1. Always negative 1. But in a superoxide, it will be negative 1 over 2. Okay? So oxygen in its most compounds, it is negative 2. But in peroxide, it is negative 1. In superoxide, it is negative 1 over 2. So that was about the oxidation and reduction reaction. Let's see an example or a diagram. Actually, it's an example about oxidation and reduction reaction. Now here, like for example, Na plus Cl2 will give us 2NaCl, right? Okay, Na plus Cl2 will give us 2NaCl. As I said before, that there is a rule which says if the element in its free state, it will be normally 0. So the oxidation number for sodium and chlorine is 0. And what we have here, 2 sodium and 2 chlorine. Now it is a compound. So Na, it will be plus 1, and chlorine, it will be negative 1, because chlorine is in the halogens group, which is group 7. Okay, now what we will do here, I think in the reactant, sodium was 0, but in the product now, sodium is positive 1. So there is a change, right? Okay, here what we have, Cl2 chlorine, which is 0, now it is negative 1. So there is a change from the reactants to the products. Okay, this chemical equation or this equation or this reaction, its name is the redox reaction. Okay, now which one is the oxidation element and which one is the reduction element? Or I mean reduced and oxidized. First of all, reduced, it will be the chlorine. Chlorine is the reduced element. Reduced. And sodium is the oxidized. It is the oxidized element. Now there is a reduction and oxidation which will be have limiting and reacting agent, and we will see the differences now afterwards. But as we said before, always the first element it will be oxidized and the second element it will be reduced. And in the most of the compounds are like this. The first one always oxidized. The second compound, the second element, it will be always reduced. Now let's go for the limiting agent and oxidation, limiting agent, or reducing agent and oxidizing agent. Now let's continue by saying the difference between oxidizing agent and reducing agent. First of all, is a species being reduced? Oxidizing agent is a species being reduced, causes and brings oxidation, gains electrons, oxidizes other substances, decrease in the oxidation number, can be element, molecule, compound, or ion. Example of oxidizing agent are like non-metals. Now, reducing agent is a process of being oxidized. Here it was reduced, but in reducing agent it will be oxidized. And causes and brings reduction, contains oxidized substance, loses electrons, and here it was gains electrons. Now also reduces other substance, like here it's oxidized other substance. Here it is increase in oxidation number, but here it is decrease in the oxidation number. In the reducing agent, the same thing like oxidizing agent, which can be element, molecule, compound, or ion. And example for reducing agent is like metals. Now let's see an example about oxidizing agent and reducing agent, and about reduction and oxidation, oxidized and reduced. Now let's continue by an example about oxidizing agent and reducing agent. First of all, we have this chemical equation, which is 3H2S plus 2HNO3 will give us 3S plus 2NO plus 4H2O. Okay, first of all, hydrogen with non-metals is positive 1, so it will be positive 1. And what we have here, sulfur, which is in group sulfur, it will be negative 2. it's having their group, and hydrogen would be +1, nitrogen +5, oxygen -2 always. And we have here only one element which is in its free state, so it will be 0. And we have NO, which is nitrogen will be +2, oxygen will be -2, H2 will be +1, O it will be -2. Now, first of all, is this equation is a redox reaction or non-redox reaction? Actually, we will know about redox and non-redox reaction in the coming or in the next video, what's their difference and some of them is about them. But first of all, this one, it is a redox chemical reaction. Why? Because if there is a 0 and it changed to -2, or it was -2 and changed to 0, so that means it's a redox reaction. But if there was no 0 and all of them have an oxidation number, so that means they are non-oxidation number. Okay, now which one is the reduced and oxidized? First of all, 2HNO3 it will be reduced, and the first element, which is H2S, it will be oxidized. Always the first place, the first compound, it will be oxidized. The second one, it will be reduced. Now let's see the oxidized substance. Which one here is the oxidized substance? It is sulfur. Sulfur in H2S. This one. It is the oxidized substance, which is sulfur. Why? Because here it was -2, but in the product it is 0. So this one is the oxidized substance. Okay, because there is the removal of hydrogen. It's the removal of hydrogen. Don't forget this one. Now what we have here, oxidizing agent. I mean a reduced substance. Which one here is the reduced substance? Actually it is nitrogen. It is nitrogen, because here it was +5 and here what we have, +2. So this element we are called reduced substance in HNO3. Okay, now which one is the oxidizing agent? It is HNO3, because if it is reduced, so it will be oxidizing and it will be oxidation. Okay, but if it is a reducing agent, which will be the compound, it is H2S, because here if you can see, reducing agent is oxidized and is the reducing agent. Here it will be the reduction, oxidation, oxidizing, reduced. Here oxidized, reducing agent, and reduction. So this is the difference between oxidizing agent and reducing agent. Oxidation, reduction. Oxidized, reduced. And this was an example about redox reaction, redox chemical reaction. Now that was everything about oxidizing agent, reducing agent, chemical equations, the types of chemical equations, chemical reactions, types of chemical reactions and types of chemical equations. How to solve the chemical equations by two methods, which is Lcm method and inspection method, which is by gassing. And also what's the meaning of chemical reactions, and the meaning of chemical equations, that is a shorthand or representation for chemical reactions. That also reactants, is equal to product reactants, which means the products, the elements which react together to give us a product. It can be one product or it can be two products. Like for example, one product will give us many reactants, or many reactants will give us one product. These things. And also about the types of chemical reaction, which it was first of all combination reaction, decomposition reaction, single displacement reaction, and also double displacement reaction. And the fifth one, which is redox, reaction. And also we will see the meaning of non-redox reaction. So that was everything for today, and I hope that you benefit from this video and gain new information from this topic. Inshallah, in the next coming videos we will make more topics together, and we will discuss together. Thank you for watching and thank you for listening. Goodbye.